welcome to everyone who's attending the first siberX exchange online. I hope everyone's having a great event. I know I've been enjoying it very, very much and listening to a lot of different perspectives. So my name is Gillis. I'm the Manager of Applied Research Business Development at Durham College. I'm going to be the moderator of this session. And the title of the session is Automation of Transportation and Logistics. So we have 30 short minutes with our expert panel to explore this. This particular session is sponsored by DCAVR, which stands for our Durham College Autonomous Vehicle Applied Research Group. And that's one of the applied research initiatives at Durham College, along with our Center for Cybersecurity Innovation, our AI Hub, and our Mixed Reality Studio. And DCAVR, together with our partners, the Spark Center, Ontario Tech U, form the Durham Regional Technology Development Site, which is one of 6 regional sites in Ontario that is part of the Autonomous Vehicle Innovation Program administered by OCE, Ontario Centres of Excellence, and supported by the province. So a big thanks to the province and OCE, and a big thanks to our Dean of Research Services at Durham College, Debbie McKee-Demchuk, our President John Lavisa, and VP Academic Elaine Pop, who are big supporters of those activities. So I'm really excited. I've been excited all week long to get into this panel with our experts. So I'll just briefly introduce them and then I'll let them talk to their areas. But just in alphabetical order, we have Harsha Vachher of KTech Labs. And Harsha is a seasoned IT professional with a variety of diverse experiences in IoT, security, smart buildings, smart city, smart homes, logistics, and wearables. Next, we have Saini. Saini is Women in Cybersecurity out of University of Windsor, and she's a PhD candidate and just defended her thesis yesterday, she tells us. So good luck on all of that, Ikjot. And she's got a number of papers to her credit around vulnerabilities of connected and autonomous vehicles, and she's the founder of the first student chapter of Women in Cybersecurity. So welcome to our panel. We also have Jason Lee of SmartCone Technologies. Jason is the founder and CEO of SmartCone Technologies and spent much of his career developing new technologies that make the world a safer place. And he's spent time in Kuwait and Afghanistan researching military applications in this area. And he's now bringing those solutions to the private and public sectors. And Juan Araya. Juan joins us from in and around Madrid. And Juan is with Tata Consultancy Services. He's the cloud security lead there, a seasoned IT professional, and he's focused on cybersecurity for the last 8 years. Has led many, many projects, and so welcome, Juan. We're very excited to have you there. So maybe just to kind of get into this fairly quickly, I think when most people think of autonomous vehicles, at least I've observed, they tend to be thinking of the fully autonomous vehicles, and connected might be an afterthought, if at all. But it's really not what we're seeing today as we see manufacturers work through the various levels of autonomous or automation. So let's get into this, and I'll maybe the first question to Harsha. And just, when you think of an autonomous vehicle, and it's more than just a car connected to the internet. So I'd like you to kind of tell us how you think about autonomous vehicles, and in a minute or so, tell us what areas of autonomous vehicle side of things and maybe infrastructure you've decided to focus on, Harsha.
Thank you, Chris. So for me, autonomous vehicle is a vehicle that is equipped with sensors, actuators, and have complex algorithms and machine learning systems. They have this capability to sense the environment and operate without human involvement. So for me, the side of autonomous vehicle, how I look into is the infrastructure side. How autonomous vehicle connects to the network infrastructure to transmit data, charging stations where we have different ports that the vehicle connects to for the charging. Plus, in future, we are also looking for the possibility to connect vehicles with other infrastructure like smart homes, smart buildings, and other smart things in the network. That side of the network area is where I am focused into, more on the network infrastructure side, smart home integration, and smart building integration.
All right. Okay. Thank you very much, Harsha. And maybe Ikjot, how do you kind of talk to how you view autonomous vehicles and your area of specialty in this whole world?
My area of specialty is connected vehicles, very close to what Harsha just said. But my work was related to connected vehicles and V2X technologies. So the standards and policies are still in progress for that. But what we are going to see in future is two different sides of autonomous vehicles, where one autonomous vehicle itself have 5 levels of autonomy, going from level 0 to level 5. And today we are at, people say we are at level 3, but I consider most of the general engineer also would say it's 2.5 of level of
Okay.
autonomy. So heading forward, we will be having level 3, where we might not be having a driver taking charge of the vehicle. And then connected side of the like with the self-driving car, it's just not the autonomous vehicle. How would it sense would also rely on this lidar, GPS, and other sensors and actuators, as well as there will be information from the environment and the surroundings, which is not in the immediate surroundings of the vehicle itself. So that's why there is a need of communication. So that's why we need V2X technology, which can enable smart homes, smart cities, all those IoT or Internet of Vehicles. That's cyberspace will be different than what we are going to see. There will be two different cyberspaces. One will be on the Internet of Vehicles, another layer would be within the vehicle itself. So today we have like canvases. In near future, we'll have more sensors and actuators than what we have today. So we need to secure them. That means what kind of deep learning, machine learning that we are using. So we need to protect all those adversary attacks on those learning methods. That's how I see autonomous vehicles. And
Interesting. Okay, we'll get into that a lot more as we get into this. So, Jason, you've actually some pretty interesting IoT type technologies. How do you see autonomous vehicles, the whole infrastructure, vulnerabilities, and what areas are you choosing to focus on?
Well, the first one is the practical implementation from an infrastructure perspective. So our sensors are things like on the ground. I think the autonomous market involves more than just an autonomous vehicle. I think even self-driving cars, connected cars, pedestrians, drones, VTOLs, all these things all play the same level of information sharing from a connected perspective that an autonomous vehicle is going to interface with.
Mm-hmm.
And I also think that our approach to it is more of biometrics. I mean, identifying and cybersecurity is something from a financial institution and from access control that the world has been solving for people forever. And so it's difficult now when you think about how a person stays safe, and then you move to all the systems on a vehicle. But so what SmartCone is spends our time on doing with our patents and our innovations is looking at a vehicle as if it was a person. So authenticating a vehicle in time and space, where it is, when it is, those things makes it really dynamic from a from a hacking perspective. To make it very difficult to hack and track and all these things is really, what we want to do and what we're doing now. And that using the infrastructure in collaboration with those autonomous or semi-autonomous systems is a really great way to do that, because you can create a physical barrier or difficulty with even accessing a car at the same time, and when with blockchain and this and that. And it just really makes it a very, very difficult environment for anybody to hack. And that's our approach to it.
Yeah, that's interesting, and I see a lot of nods in from the members of our panel here, and that'll be interesting because as we get into this, the whole issue of the vulnerabilities and how we prevent hackers from getting into the systems, and that something I'd like to go down that road. But let's hear from Juan now. That in terms of how do you see autonomous or connected autonomous vehicles, and what areas have you chosen to focus on in your practice?
Okay, so first of all, thank you very much for this opportunity. So definitely, I think that I agree with Jason that autonomous system not only includes self-driving cars, it also includes many other technologies like drones, like he mentioned, internet connected cars or vehicles where you can control them remotely, where you can do a lot of things. And as you know, this technology is not only for end users, but also has been used in a while for military purposes. So that's why this type of technology needs to be not only used properly, but also secure against different type of attack vectors. Because the damage could be critical. You know, we're talking about life of people that could be in danger. So where I would like to focus more on or see more, a little bit more of research will be more in infrastructure. And for example, most of these vehicles are connected to the cloud. So how to secure that connection, you know, no matter if they do it by Wi-Fi, no matter if they do it using the cellular APN, no matter how they connect, to do that connection, you know, in a secure way, using the OTA, you know, over-the-air technology in a proper way, in a secure, in order to avoid ransomware, in order to avoid malware to be injected, in order to avoid man-in-the-middle attacks and so many other attack vectors.
Okay, interesting. And I think from what I've seen is that some of the cities in Spain have made a lot of progress in this area. Have you been involved in any of the projects out of Barcelona and places like that working on this?
I'm more involved on the cloud security perspective,
Okay.
you know, in other words, to protect where the repository of the different new versions are stored, in order to avoid those type of sources to be affected against denial of service attacks, as an example. So that would avoid the device to receive, you know, the information, to try to protect them against different type of information leakage attacks
Right.
and different type of layer 7 attacks. So I'm more involved on the infrastructure and cloud protection.
Okay, great. Thank you for that.
Sure.
So it's interesting, and you know, I think when we, as I said, when we opened up, I think a lot of people, when they think about all of the security side of things with autonomous vehicles, think an awful lot more about the vehicle themselves. But I think, as we were saying, that there's an awful lot more infrastructure out there than vehicles. And I thought maybe I would throw this one to Ikjot to start with, and then get everyone to chime in. But you know, as you say, these vehicles are in fact being hacked on some level right now, and they'll continue to be hacked. And so maybe you could talk about some of the vectors that you see as entrant for hackers or the bad actors, and your view on the types of things that we maybe need to start to work on more to try to prevent all of the access to those systems.
I believe you're on mute. I can't hear you.
Can you hear now?
I can hear you now.
Yeah.
Perfect.
Sorry about that. So I'll start it with the three parts of for this answer. So if we are having a level 2.5 autonomy, then how we are going to have like today we have the CAN bus, and then we need to prevent the attacks on the CAN bus itself. But the problem relies how the attacker is going to get into the network itself. So that means the connection, even though it's with the infrastructure or in any other way. So first of all, how to get into the network and have the active attack. So that is the main attack vector. Next, going into the vehicle, there are so many parameters and sensors and actuators, so much information, and need to protect that. And if we are building new level of autonomy, then we need to take care of how can we prevent or mitigate those risks in the design itself or the system design. Moving forward with a higher level of autonomy, we are going to have more integrated systems around in the smart cities. It will be like whole smart network. And I believe the injection of any of the cyber attack starts with the network and then further moves into the systems, and then it spreads, right? So I would say the first potential attack will be most likely to be on some infrastructure unit. So that's why everyone on the panel have mentioned how important it is to have infrastructure units. But I would say they need to be secure as well, or attack resistant. And I have, in the research or academia, we have seen very less work done on this side. So there is more focus on networks and communication and how we can secure it, but not the hardware level security. Like there are problems with the spectrum, or there are so many Trojan horses and so much going on. But we need to focus on each individual, all those attacks, and need to have attack resistance infrastructure units. Related to autonomous vehicles, we need to have intrusion detection systems and intrusion prevention systems. So those are also important. Moving forward, there are different types of sensors and actuators. So each one of those have their own adversary threat, or they have threat models different for them. For example, it's just so how a self-driving car would know or sense, it uses certain cameras, right? So how can an adversary, rather than going on the network itself, how can it physically impact? So there are these levels of the attacks as well, which are in physical.
Okay, interesting. Thank you.
Hey, Chris, we just had we had a question. A question came in to the panelists. I answered, so they want me to answer verbally, which I'm going to do now.
Perfect.
The question was, let's see here. Question comes in: autonomous vehicles have been receiving mixed reviews since Tesla had an incident. Can you provide some light on how that has impacted innovation and development on autonomous vehicles? My answer to that was that it's put a much needed focus on the collaboration of infrastructure. You know, in like any new technology, we try to push it forward as fast as we can with all the bells and whistles and so on and so forth. The reality is that the real world environment with people in it is so dynamic and far beyond the capability of just one system alone, that you need to have collaboration with multiple systems like vehicles, collaboration, infrastructure, new laws, training. There's a lot that needs to go into it. And I think that those accidents draw light to the fact that we're not ready just with one system alone to do the job. And so from our perspective, it certainly has put a much needed focus on the infrastructure component.
Yeah, that's really important, Jason. And we wonder, Harsha, given your building and smart city perspective, how would you kind of reply to that?
Yeah, so I would say yes, definitely standards will come in place when it comes to smart cities and infrastructure. So what I'm focusing on is the network infrastructure and the connecting points of the vehicles, like the ports the vehicle used for charging or different connections, and then connecting to cloud and other infrastructure. So definitely standards are there in place, and then OEMs are also setting up standards for different ports and different network infrastructure connecting points. So how I look is the integration where the data sharing between vehicles, smart homes, and other Internet of Things comes into play. So how this integration will come into play is the key area, and different standards coming from NIST and few organizations in UK that are working on how data is to be shared among Internet of Things is the key area of focus, and that's where I'm looking for.
Okay, great. And I don't know, Juan or Ikjot, do you have anything to add to that? Or
I just want to add the following. When we're talking about an autonomous system, we're talking about a system that has a very wide attack surface, where someone can attack from a USB, from a connection, from a Wi-Fi connection, from directly connecting, to the diagnostic port of the car or the device. So there are so many attack vectors that they can use, and also the infrastructure, that I think that it is important, as one of our peers mentioned, to have a IDS and IPS system and also active monitoring to be able to detect those patterns proactively and be able to notify, in case something is wrong in real time, if possible. Also securing OTAs. OTA, I can't get tired of saying that, because OTA is so important, because when you are using a machine that has all firmwares, that has all software, that has vulnerable applications, and there's no 100% secure software. There's no. You will always find something. I work as a pen tester also, and I know how to find those type of small mistakes that you will find over and over, even in high and complex and corporate software. You will find those type of mistakes. So, yes, please go ahead, Jason.
Just on that, Juan. Is that how we say Juan? Is that
Juan.
Okay, Juan, how my philosophy on that is that sometimes, because we're people who build autonomous systems are really smart, but they forget to make the system stupid. You know what I mean? Like at the end of the day, it's a complex thing for something to traverse around an area without trying to make too many critical decisions. So, for example, if it was anyone and we were a person and we were an autonomous vehicle, typically when you are afraid or you don't know, you stop. You don't continue to go faster. You don't make decisions to put you in a tailspin. And so, I think in some of these behaviors that a machine learning and onboard intelligence system could do is just know when something doesn't feel right. And when it doesn't, divert to a safety protocol of just stop. You don't need to make all the complex decisions. It's more important to do self-diagnostics and to know when something is wrong. And as soon as you detect that, pull over. Because even if you pull over and no one's hurt and you disrupted service, it's better than having somebody send a command of something that's going to disrupt something or cause a bigger problem. And I think that that's where, to me, that where we miss it sometimes because we're so smart. We should learn to make the system stupid. Just if you're not getting exactly what you need, pull over. And we'll learn from that, because I hate when my car pulls over. Okay, but what's the root cause analysis and how do you build it? And then add the layer. Let's not shoot for the whole thing all at once. Let's make sure that we understand that the safety is important and understanding anomalies. And if we find one, it's okay to pull over. That's what we would do.
Yeah, and that's a really good point you make, Jason and Juan, that you have those need to make these systems kind of as it were. Some of the stuff I've been reading lately, especially around the connected vehicle side, indicates or points to that a lot of the car companies are building on legacy software. And so there are a lot of vulnerabilities already built in. So I'd just be really interested in the perspective that how the panel has on what are areas that maybe need to be done to research or look at, as Jason, you said, how to make the system dumb and much more robust. So I'm not sure who wants to take that one on.
I would start on this. So as you said, the system is developed on legacy software, making it more vulnerable. And we all know cyber risk is of particular concern to insurer, regulator, and OEMs. So this all leads to the need of a risk assessment system. So at KTech Labs, we have a cyber risk assessment framework for smart buildings and smart homes. So I'm more interested in extending that cyber risk framework for autonomous vehicles. So what this framework will do is it would help to understand the risk in a vehicle system vulnerability. So the model how I propose is consider vehicle as a sum of its hardware and software components, and then design a risk scoring framework by utilizing the software vulnerability and the hardware configuration of the autonomous vehicle. Based on this, come up with a cyber risk rank of the vehicle system. This model then can be used by insurer or a vehicle manufacturer or a supplier to classify the risk of autonomous vehicle using the known system vulnerabilities.
Okay, interesting. And in your work, I'd be really interested in your perspective on this.
Did you ask me?
Yeah, sorry. Just in terms of the vulnerabilities and what Harsha was talking about, the need to make the systems dumb or more robust, and the need for some sort of a standard or a test method. You've done work in terms of looking at the vulnerabilities. I'd just be interested from your point of view how you see this maybe rolling out, or what your view on it is.
Regarding there are a few other points too. I just want to mention them before. One of the critical thing about autonomous vehicle is the ethical issues. I think Jason touched on it, but didn't say it in this way. But we, when we are designing these vehicles, we are missing out how it will react in situations where it has to pick out of, let's say, two of the situations which are both harmful. It would not even stop, maybe, because of it doesn't have that kind of a learning till that point, and it might hit somebody or might choose that over the other situation. So that is one of the, like, it's a machine learning and deep learning, that side of it, but still it needs a lot of learning and a lot of, I would say, rigorous learning on that side, so that we as customer, when you're buying a vehicle which you are going to be sitting in, you should be accepting that risk if it's a risk, right? So one of the questions, I think it was popped up regarding how you're going to regarding the Tesla. So it's not just Tesla. I recently read about Waymo. they had 21 attacks from people, and they tried to have the adversary attack in physical as well towards this car, because public is not ready for this, and they are trying to push it back because they see that it's a threat for them because it's not properly ready. So the vulnerabilities are on the other side, and there is this side where we don't even, as public, we are not accepting as it will be rolling out. So that means we need more stringent standards, some sort of laws and policies. Legislation also plays a big role in this. Let's say in Ontario we have capabilities and everything, but it becomes slower or late or delayed, then that would be a problem as well. So overall, we need all other aspects as well.
All of those. And I'm just looking at a question here, and I'm wondering, someone's asking, will 5G impact development of autonomous vehicles? Do you see that making the situation worse or better?
Just before she jumps onto that one question, just to tail on what you just said, which I think was great, by the way. And I think the one thing that we need to add to all that is just the paradigm insertion, that we have to understand how the public works now and how they want to work with the insertion. And it can't be a jagged perpendicular approach to introduction. It has to be a collaborative way that we can ease people into a comfort level of paradigm understanding. And I think with that, on top of everything else, would be good. Anyway, sorry, go ahead and answer the 5G question. That's good.
No, that's okay. Anyone want to hop in on 5G? What's your perspective?
I can jump on it right now since I go off mute and then hand it around. I'll be quick. I think the 5G thing is any kind of bandwidth you can get with faster time slicing and network protocol and all these other things and built-in cybersecurity issues is great. But I think that autonomous networks have built this far already without it. And I think that it's going to continue to grow without it. It's an enabler. That's great. I think all the help can be better. But I don't, in my personal opinion, I don't think it's going to play a huge role in the short term. In the long-term rollout, when you have a lot of vehicles in the smart city and capacities are an issue, we solve all these problems in a few years from now, I think it'll play a bigger role then.
Okay, cool.
I can add on to that.
Okay, please.
So in connected vehicles, there are two sides, two different types of communication. One is vehicle to vehicle, where we are dealing with more safety applications and more strict real-time constraints and all those situations where we cannot compromise time safety, right? In that case, there's a technology called DSRC, dedicated short-range communication, and recently it has its own spectrum, and everything is different than what we are using in cellular. So another side of the communication in vehicles is vehicle to infrastructure, where we can actually use 5G, and it can be really fast, and it can be the other side of it, but it's really not a good idea to just mix both of them. And recently, for a few months, since November, there's a huge debate going on, not in Canada, but like can say North America and US specifically, that they want to introduce more of a cellular V2X rather than just having DSRC. But overall, if you are looking from again, public's point of view, they don't want to compromise with the safety. So it's really important to just keep 5G for cellular and entertainment and vehicle to infrastructure units communication, rather than just introducing it within the safety applications in V2.
Okay, thank you. And I'm just wondering, as I mentioned, the Haven communities got a number of test beds and/or regional technology development sites providing assistance in this area. And Jason, you've had some work with some of those, but if you had some last words, each of you, on what areas of cybersecurity should these sites focus on to provide the best assistance, maybe what type of things or what advice would you give people now? And maybe Harsha, I could start with you and we can go around the panel.
I would say focus on understanding the risk. Develop a risk assessment framework that tell you what are the system vulnerabilities now and in future, forecast using the test bed.
Oh, great, thank you. And Juan, do you have anything to add that you would suggest as a focus for supporting future development for cybersecurity?
So from my side, I think that first of all, it is important to motivate people to get more familiar with this technology because this is the future. Sooner or later, we will see more and more, autonomous vehicles, not only for transportation of people, but also for transportation of food and other goods. So it's going to be part of our day-to-day operations or day-to-day life. So that would be the first thing. And second, I think that we should focus more on the detection and prevention and mitigation of possible attacks because there are many type of attackers from hacktivists, people that are going to be like APTs, advanced persistent threats, that are going to try to perform a lot of attacks. Even state-sponsored attacks will be performed, to try to affect, the technology perform. I don't know, developing in Canada, so another country will try to hijack or damage, the reputation of the technology that you guys are developing in Canada. So I think that's why it is important to try to focus more on that, on detection, mitigation, proactively comparing standards, as Harsha mentioned, based on NIST, following best practices. Because again, software, I still think that having old firmware, it's a very high risk. Let's make a very simple example. How frequently a computer, drivers for a computer are developed. They are not developed so frequently, right? Every, I don't know, 6 months, and some computers, brands, they take even more time to release a new version of a firmware with hot fixes and vulnerabilities fixes. So that's why we need to focus on that, detect, fix, and release as soon as possible.
And I think, Chris, I think that just on a parting thing, and then there's one more last question, but the thing I'd like to see at these test centers is somewhere to have where you actually have brute force attack in a controlled environment like that, to actually see what can be done, what is the level of danger, like actually focus on hacking it, taking it over, and see how that disrupts it in a very controlled environment. We'll make it real for everybody to see how that actually rolls out.
That's a great suggestion, Jason. Certainly it would. And unfortunately, we're at time for this session. But, we can see that this is obviously a conversation that could carry on for much, much longer. So maybe we'll get a chance to do that at another point. But I would just like to end by thanking all of the panels, Ikjot, Harsha, Juan, and Jason, for participating in this particular session. And I'm assuming if anyone wants to find out anything more in these areas, they can contact you and talk to you directly. So thank you all very much, and hope you enjoy the rest of the afternoon.
Thank you very much, Chris. And more jobs, not less. All right, everybody, have a good day.
Yes, absolutely.
Okay. Thank you, guys. Bye-bye.
Bye now.